3 girls and 2 boys are to be seated in a row. Find the number of different ways that this can be done if the girl and boy sit alternate. So we have the boy in the middle. So over here is 2 factorial. And the girl here, this is the 3 factorial. Okay, so this will be the answer, equal to 12. Okay, so actually we can also do in this way, this 2 times 1, and then for the girl here we have the 3 2 1, so this will be 12. Next, B. A girl sit at each end of the row. So we have the girl sit at the end here, so 3 2. Then in the middle we have 3 left, 5 minus 2, then we have 3 left, so 3 2 1. Okay, so 36. Okay, so this one first place is girl. So out of 3 girls we have 3 possible here. So after one girl sit here, another girl will sit here also. So after we use one girl here, then we have another 2 girls here. So after we use the one girl and one girl here, so we have 2 girls used, total 5 boys and girls. So 5 minus 2, we have 3 left. So in the middle we have 3 2 1. Okay. Next, the girls sit together. So we have the girl, and the boys sit together, boy. So this one we have 1 2 factorial, and then the girl have 3 factorial and the boy is 2 factorial, boy girl. Okay, so we have 2 times 6, 24. Okay, so question number 7a, find the number of different arrangement of the letter in the word orange. Find the number of this arrangement. So number of arrangement letter from orange, 1 2 3 4 5 6. So we have the n equal to 6, so it is 6 factorial. So 6 factorial, 720. Okay, B, begin with O. So begin with O, then we have 1, then 5 left here, 5 factorial. So this will be the 120. 6 minus 1, then we have 5 left here. Okay, A, O at one end, E at the other end. So we have the O, E, or the E, O. Okay, then out of 6 we use 2, we have 4 left, so 4 factorial. So 4 factorial is actually 24. So this is 24. So 24 plus 24, so it is 48. Find the number of different 6-digit number which can be made using the 0 until 5 without repetition, cannot begin with 0. So we have 5. Then we have the 5 factorial, 5 times 5 factorial. Okay, so we have the 5 times 5 factorial, so it is 600. And then B, how many of the 6-digit number part A are even? So even it must be n with the 0, and then if it's n with 0, and then it can be n with 2 or 4. Okay, if it is n with 0, then we have a 5 4 3 2 1. Okay, so this is actually 5 factorial. Okay, 120. And this one is use 2 or 4 here, then here don't have 0. So if I use the 2 here, if it is 2 here, then what they can have is the 1, 3, 4, 5. If I use 4 here, then I can use 1, 2, 3, 5. So I have 4 choice here. Then 2, 4, 3, 2, 1. So we have the 4 times 4 times 3 times 2 times 2. So it's 192. So the total is 120 plus 192, then it's 312. Okay. So for the A here, it is a 6-digit number, cannot begin with 0. So it can begin with 1, 2, 3, 4, 5 out of this 5 number. Then over here, this part is actually we have 5 number left. So we have 5 possible, 3, 2, 1. Then this one is actually 5 factorial. So for B, part B here, we end with 0 here. Then we can start with the 1, 2, 3, 4, 5. We have 5 possible. And if we end with 2, then we can start with 1, 3, 4, 5. We end with 4, then we can start with 1, 2, 3, 5. Okay, so for this question, actually we can do it the other way. So I have 6 cases. So let's say we start with 1, 2, 3, 4, 5. And then I cannot start with 0 cannot start with 0. Okay, 1, 2, 3, 4. Then the next 5 number here. Okay, so to make it even number, so I can put 3 possible here, and this one also 3, this one also 3. Why it is 3? Because we can put 2, 4 and the 0, 0, 2, 4 here, end with 0, 2, 4. And this one also end with 0, 2, 4. This one also end with 0, 2, 4. If we start with 2, then I can end with 0 and 4. And start with 4, we can end with 0 and 2. So here 4 factorial, 4 factorial, 4 factorial, 4 factorial, 4 factorial. So we have the 4 factorial times 3, 72. 72, and then 4 factorial times 2, then it is 48. So total will be 3 times 72 plus 2 times 48. So we have 3 times 72 plus 2 times 48, then it's 312. Okay, so this one also 312. So just now that one I also can do it the same with the first method. So this is the first method. We start with the ending point. So this one is the second method. We start with the starting point. So the ending point, I can make it 3 cases. So we end with 0, end with 2, and end with 4. Then it is even. So if end with 0, then this one we have 5 possible. Because we can start with 1, 2, 3, 4, 5. Okay, so this one we can start with 1 until 5 here. Okay, and then this one is here 2, then we have 4 here, because we cannot start with 0 and 4. Then we can start with the 1, 2, no 2. Okay, we cannot start with 0 and 2. We can only we can start with 1, 3, 4, 5. and then this one we cannot start with 0 and 4, then we can start with 1 2 3 5 4 here, 4 factorial 4 factorial 4 factorial. So we have the 5 times 4 factorial, then it's 120, and then 4 times 4 factorial, then it is 96. So 120 plus 96, that's 96. So we have times 2 plus 120, so it's 312. Yes, correct. So question number 9 I record in the other video.